Good morning. Today I'm going to discuss about class 12 chemistry related to chapter haloarenes, chapter 9 haloarene. It is most important chapter. And then the property of the haloarene. Today I'm going to discuss about the property of the haloarenes, and then related to the physical property and the chemical property. And at first of all, point number 1. Today I'm going to discuss about the property of the haloarenes. Properties of the haloarene. Then at first of all, now I'm going to discuss about at first of all physical properties. At point number 1. Point number one is physical property. Physical properties. Point number 1, physical property. And at first of all, point number A, haloarenes are the colorless oily liquid or the crystalline solids with the characteristics pleasant smell. That's characteristics pleasant smell. And haloarenes are like a colorless oily liquid. Colorless oily liquid or crystalline solid with a characteristics pleasant smell, like a characteristics pleasant smell, with a characteristics pleasant smell. Characteristics pleasant smell. And the second point is point number B, chlorobenzene is colorless liquid having the 130 degrees Celsius and sweet smell, like a sweet smell. And the smell of the chlorobenzene is like a sweet smell. Chlorobenzene is a colorless liquid having the 132 degrees Celsius and a sweet smell, like a sweet smell. And point number 3, like haloalkanes, they are insoluble in the water due to the lack of the hydrogen bonding, while soluble in the organic solvent. Then like a soluble in organic compound, but they are not soluble. They are not soluble in the water due to the lack of the hydrogen bonding. Like point number C, like a haloalkane. Haloalkanes, they are soluble. They are insoluble. They are insoluble in the water. Due to lack of hydrogen. Hydrogen bonding. While soluble in organic solvent. Organic solvent like organic solvent means like ether, alcohol, etc. Like ether, alcohol, etc. And point number D. In the point number D, given that they are heavier than the water. Like I think that the haloarene are heavier than the water, so that it is most heavier than the water, and they are heavier than water. and the density increase with the increase in the atomic mass of the halogens, and so that the highest atomic mass of the highest density of the highest density is hydroarene, and then the bromoarene, and then the chloroarene, so that the density increase with an increase in the atomic mass of the halogen, so that greatest density is hydroarene, and the next bromoarene, and the next less than the hydroarene, less than bromoarene, and less than the chloroarene, so that point number E point number E haloarene and haloalkane containing the same number of the carbon have the nearly the same melting point and the boiling point. The boiling point of the haloarene is higher than that of the hydrocarbons having the comparable molecular mass. This is due to the greater magnitude of the van der Waals force developed by the polarity of the carbon X bond, and X means a halogen bond. And for the same oral group, the boiling point increases with the size of the halogen atom, so that the hydrogen is the melting point, the boiling point of the hydrogen is heavier than the bromobenzene and the chlorobenzene and the fluorobenzene, so that hydrogen is heavier than the bromobenzene and chlorobenzene and the fluorobenzene, so that the boiling point of the hydrogen is higher than the bromobenzene and chlorobenzene and the fluorobenzene. But in the case of the isomeric dihaloarene, boiling point are nearly the same, but the melting point of the isomer is quite higher than that of the auto and the meta isomer, so that this due to its symmetrical structure, which leads to more close packing in the crystal lattice, so that the the 4-dichlorobenzene is higher than the boiling point. The boiling point of the 4-dichlorobenzene is higher than the 3-dichlorobenzene and 2-dichlorobenzene, so that the melting point and the boiling point is higher for 4-dichlorobenzene, so that the 4-dichlorobenzene is heavier it's higher than the 2-dichlorobenzene and the 3-dichlorobenzene, so that the 3 means meta and auto means 2 means ota, and the p means paro, and then the haloarene has a dipole moment due to the presence of the polar carbon halogen bond, since the halogen is more electronegative than the carbon, so that the halogen group is most and more electronegative to the carbon, so that carbon is less electronegative than the halogen atom. However, the dipole moment of the chlorobenzene is less than the chloromethane, so that is in the chlorobenzene bond is sp2 hybridized, where it's in the chloromethane as the CCl bond is sp3 hybridized, as sp2 has more s character and more electronegativity than the sp3, so that as a result the electronegativity difference decreases between the chlorine and the carbon, which makes the dipole moment of the chlorobenzene lesser than the dipole moment of the chloroethane. So that next I'm going to discuss about chemical properties. And chemical properties of the oral halide are due to the aromatic ring and the halogen atom. At first of all, point number one, the reaction due to the halogen atom. Then the another name of the reaction is the nucleophilic substitution reaction. And the chemical then next I'm going to discuss about chemical properties. And at first of all, point number one, reaction due to the halogen atom. Reaction due to the halogen atom. Reaction due to the halogen atom. The another name of this compound, this reaction is the nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic substitution reactions. And at first of all, and I'm going to describe about reaction due to the halogen atoms. And generally, the nucleophilic substitution reaction are the characteristic reaction of the haloalkane, but not true for the haloarene. Haloarene, in the contrast to the haloalkanes, are less reactive towards the nucleophilic substitution reaction. So that the reaction, the reason for the low reactivity of the oral halide can be explained based on the following the facts. Fact number one: resonance effect. The halogen atom in the oral halide is strongly bonded. In the resonance effect, fact number one, the resonance effect, resonance effect. Fact number one, the resonance effect. And the resonance effect, the halogen atom in the oral halide, is strongly bonded to the aromatic ring. Then the for example, is chlorovenzene. Now I'm going to describe describing about the chlorovenzene by the resonating effect, Cl. And then the there are six electrons. There are contained in the 6 electrons in the chlorovenzene, so that electron is attack this bond, and this bond is formation. This one is breakdown, and then this is the name of this compound is chlorovenzene. This name of this compound is chlorovenzene, and describe about chlorovenzene. I'm going to describe about chlorovenzene, and cannot aromatic ring, and cannot be easily replaced by the nucleophile as compared to an alkyl halide. So this is due to the tendency of the halogen atom to share its electron pair with a ring to the product for this resonance, which provides stability to the haloarene. Due to this, the halogen atoms shows the double bond character with the carbon atom of the ring. Thus halogen is more strongly held up with a ring because of the shortening of the atom of the ring. Thus the halogen atom is more strong, and the carbon atom the bond length. And for example, carbon covalent bond length in chlorovenzene is 1.69 angstrom, another which is much shorter than that of the single carbon CCl in the alkyl halide. So that 1.8 angstrom, including the some amount of the double bond character in the CCl bond. So that the transferences of the lone pair of the electron produces resonance, and thus increase the stability of the haloarene. For example, chlorovenzene can be represented by the following the resonating structure, and then the this is resonating structure of the chlorovenzene. Then the another structure is, then there are double bond in chlorovenzene and chlorine. There are 4 electron and positive and Z positive, and auto there are negative sign in the auto position, and then the attack in this point, and this bond is breakdown on the para position. Then another structure is another structure, and then this bond is received into in this position, so that this is bond, and there are a negative sign in the para position, and then the attack in this point, and this bond is breakdown, and there are double bond carbon chlorine. There are four electron contained in chlorine. There is a positive charge. There is a content in the positive charge, and so that then another structure is 1 2 3. There are three bond, three structure, resonance structure, and then double bond. On double bond chlorine, four electron, and this bond is received in this point, and negative sign is contained in the chlorobenzenes, and then this bond is attacked in this point, and this bond is break down in this point, and positive sign, and at last and this one is contained, and this one is there is positions, and at last single bond chlorine in single bond, and there is a single bond in chlorine, and 6 electron, there are 6 electron in the contained in chlorine, and at last probability structure, we can conclude that this figure, this regional structure, and the hybrid structure, the regions hybrid, we can show that region hybrid, and carbon is partial double bond, and there is positive, there is content in positive charge, and there is negative charge in the O2 position, and there is partial bond, and there is a negative sign and negative charge in the O2 position, and this is called para position, and there is negative charge contained in the para position, so that the name of this resonance is resonance hybrid. This is called the resonance hybrid, so that this is called the resonance effect of the chlorobenzene, so that it is most important, and figure the resonance into chlorobenzene. resonance in chlorobenzene. And name of this resonance is name of this compound is resonance in the chlorobenzene, so that next factor is hybridization effect. It is most important. Hybridization effect is most important, so that next I'm going to discuss about the hybridization effect. Next fact, point number 2 fact, hybridization effect. Hybridization of the carbon in the haloarene is sp2. We are already know, so that while it is sp3 in the alkyl halide, so that the carbon with the sp2 hybridized is relatively more electronegative, so that than the carbon with the hybridization. Thus the halogen atom in the haloarene is more strongly held to the ring, and cannot easily replaced by nucleophile during the electrophilic substitution reaction, due to the above the regions haloarenes are less reactive towards the nucleophilic substitution reaction, so that now I'm going to write down on structure hybridization effect. Name of this compound is chlorobenzene. And chlorobenzene, the length of the chlorobenzene is 1.69 angstrom, and another this is called haloarenes. It is contained in the haloarene, and the next carbon, hydrogen, Cl, this is haloalkane, and the haloalkane of the length of the haloalkane is 1.80. So that this is compared to there are two compared to the as the highest bone length is the bone length is haloalkane. So that then the compared to the chlorobenzene. So that chlorobenzene is more strong. Haloarenes most strong to help to of the ring, and cannot easily replace a nucleophile. Then that cannot easily replaced by the electrophile. So that during the nucleophilic substitution reaction, and in case of the alkyl halide, then the nucleophile is easily replaced by and easily replaced by the nucleophile during the nuclear substitution reaction. So that the haloarenes is less reactive towards the nuclear substitution reaction. Then the hybridization of the haloarene is sp2 hybridase, and the hybridization of the alkyl halide is sp3 hybridization, and the name of this figure is CCl bone length in the haloalkane and haloalkane and haloarene. Haloarene, however, under the special condition, halogen atoms can be substituted by the nucleophiles. Some common nucleophilic substitution reactions are below. So that point 8, first of all, point number 1, substitution by the hydroxyl group. Then the another name of this compound is formation of the phenol, and it is most important. So that let's I'm going to discover about the substitution by a hydroxyl group. Then the another name of this compound is formation of the phenol. And first point number 1, substitution reaction, substitution by a hydroxyl group. Then the another name of this compound is formation of the phenol. And first of all, chlorobenzene when heated with aqueous sodium hydroxide in the drastic condition means at 350 degrees Celsius under the 300 atmospheric pressure gives a sodium phenoxide, which on the acidification gives to the phenol. This is the commercially method of the preparation of the phenol used by the Dow's chemical company USA, and the process is called the Dow's process. And then the another name of this compound is this process is the another name of this process is the Dow's process. So the Dow's process because the phenol used by the Dow chemical company USA. So that the name of this process is the Dow's process, and it is most important. And at first of all, chlorobenzene. This is a chlorobenzene. Name of this compound is chlorobenzene. This compound is chlorobenzene, and reacted with the aqueous sodium hydroxide in presence of the 300 this is called the drastic condition, 300 atm pressure and 350 degrees Celsius temperature. Then to give the name of this compound is sodium phenoxide. Name of this compound is sodium phenoxide, and the further acidification, then to give the further acidification means the dilute HCl and the acidic medium, and then to give the at last then to give the product OAS, and this is called the name of this compound is phenol, and the side product is sodium chloride. And then the attachment of the electron withdrawing group like nitro cyano carboxylic carboxylic acid. This is called there are called electron withdrawing groups. So that the like a nitro group, cyano group, carboxylic group is there are like withdrawing electron withdrawing group. So that it is called the electron withdrawing group. And to the ring the ortho and the para position increase the rate of the nucleophilic substitution. So that another compound is then the another compound and Cl NO2 NO2 is directly attached to the ortho position, because NO2 group is electron withdrawing group. And name of the disposition is ortho, and the name of the disposition is paro, and the name of the disposition is ortho. So that the always would electron withdrawing group is directed to the ortho and the paro. So that electron withdrawing group like nitro, cyano, carboxylic acid, etc. So that it is there are always attached to the ortho and the paro position. So that it is called electron withdrawing group. And then to give the reacted with water, and then to give the infusion of worm and dilute the cell in acidic medium, and then to give product. OS, this is in this position containing OS and the NO2 and NO2, and the name of this compound is 2,4,6 tri 2,4,6 tricolor. Name of this compound is carefully, we are very carefully in this in the naming of this compound. So that the 2,4,6 tri nitro 1, 2, 3, 2,4,6, trinitrophenols. Phenol name of this compound is another name of this compound is picric acid. It is most important, picric acid. And name of this compound is another name of this compound is picric acid. And it is this name is a common name. So that so that 2,4,6 trinitrophenol name of this compound, and another name of this compound is picric acid. And then let's another reaction is substitution by amino group. And another name of this compound is formation of the aniline. Point number 2. Point number 2. The substitution by amino group. Substitution by the amino group. And another name of this compound is formation. Another name of this reactions is formation of the aniline. And then first of all, describe about this reaction. And first of all, chlorobenzene when treated with the ammonia in presence of the cuprous oxide means Cu2O, and 200 degrees Celsius and 60 atmospheric pressure gives the aniline. And this reaction is called the ammonolysis of the chlorobenzene. So that this reaction is called the ammonolysis of the chlorobenzene. And first of all, name of this compound is chlorobenzene. Name of this compound is chlorobenzene. And the chlorobenzene is reacted with the aqueous ammonia in presence of the cuprous oxide. Name of this compound is cuprous oxide. Name of this compound is cuprous oxide. At 200 degrees Celsius and 60 atm pressure. And then to give the product is, and then the new product is aniline, NH2, and the side product is HCl. And the name of this compound is aniline. Name of this compound is aniline. And name of this compound aniline. So that another chemical properties of the haloarene. Point number 3. Point number three or II substitution by the sine group and under name of the reaction is formation of the phenyl cyanide phenyl cyanide and it's first of all chlorobenzene when heated with a cuprous cyanide mean cuprous cyanide means Cu2 CN2 so that this is called the cuprous cyanide and or the cupric cyanide at the 200 degrees Celsius in the pyridine or the dimethyl formaldehyde this is name shortcut name is DMF DMF as a dissolvent and it gives the phenyl cyanide and under the name of the phenyl cyanide is benzonitrile and in the given in the reactions name of this compound is chlorobenzene is reacted with the cuprous cyanide name of this compound is cuprous cyanide in presence of the pyridine or the DMF stand for dimethyl formaldehyde at the 200 degrees Celsius and then to give cyanide then to give the benzonitrile or phenyl cyanide and the side product is cuprous dichloride and from the phenyl cyanide other compound or other organic compound can be obtained so that from the phenyl cyanide other organic compound can be obtained. Then name of this compound is phenyl cyanide is at first of all phenyl cyanide is in the reduction process. Reduction process means lithium aluminum in presence of the lithium aluminum hydride or sodium for ethanol then to give new product is then to give CS2NS2 name of this compound is benzylamine it's most important and completely hydrolysis in presence of the complete in the reaction the completely hydrolysis and dilute hydrocolloic phenyl cyanide is reacted with the dilute HCl. This is called complete hydrolysis process. Complete hydrolysis then to give COOH plus side product is ammonium chloride and the name of this compound is benzoic acid. It is very acidic in nature. It is very acidic in nature and another phenyl cyanide is treated with the HCl or the alkaline is H2O2. Name of this process is called the partial reduction process. Then to give the new product is then to give name of this compound is benzoamide. Name of this compound benzoamide. Name of this compound is benzoamide, so that it is most important. So that reaction is most important for the exams, for the NAV exams and NAV exams. So that I think that these reactions is most important. So that we are most prepared. This reaction from this reaction.